Okay, solving substitution. So pick a letter x or y whose coefficient is positive 1 or negative 1, preferably positive 1. So we already started, but we found that this x right here, this is technically positive 1, negative 1, negative 1, and that has a 2. So we're going to solve for this x in the first equation. So we have x minus y equals negative 7, and I add y to both sides, and I get x equals negative 7 plus y. So now this is what I'm substituting. I know x equals this, and since they're equal, that means they're the same. Okay? So knowing that, I can replace the x in my other equation with what x equals. So when I rewrite this, I have 2. And then instead of x, I'm going to plug in negative 7 plus y. And then I'm going to bring down the rest of the equation. Minus y equals negative 9. So that is substitution. We substituted the x. We replaced the x with negative 7 plus y because they're equal, right? If they're equal, doesn't that mean they're the same thing? Yes. So how do I solve now for y? Distribute. What's 2 times negative 7? Negative 14. And what's 2 times y? So plus 2y, and I'm going to bring everything else down. So minus y equals negative 9. Now what do I do? Combine my like terms on the left. I need to simplify, make sure both sides are fully simplified. So what's 2y minus y? Y, or 1y, either way. I still have that negative 14 equals negative 9. You also could have put negative 14 plus y, either way. And now what do I do to get y by itself? Plus 14 on both sides. So what's negative 9 plus 14? 5. Now, am I done? No, because do you remember from Friday, solutions to systems are a point, an x comma y point. So I know y is 5, but I still have to figure out what x equals. No. So we're going to plug it into either equation. Well, didn't I change an equation to be x equals? And aren't we solving for x? So I can use that x equals equation, x equals negative 7 plus y, and plug in y is 5, because doesn't y equal 5? So now I get x equals negative 7 plus 5. What's negative 7 plus 5?
Negative 2.
So there's my answer. Whoop, might help if you can see. Now, can I check my work with this? Yes. And you don't even really have to do any math. You're just going to type it in your calculator. So this first equation is x minus y equals negative 7. So instead of x, I'm going to do negative 2. Minus y is 5. And this should equal negative 7. Did it work? Yes. So now I'm going to plug it into the other one. 2 parentheses negative 2 minus y is 5 should equal negative 9. It also worked. Therefore, that is my solution, and I checked my work. So if we were to graph both of these lines, they would touch at negative 2, 5.
What if it's the solution or not?
We'll get there. You're ahead of me. Okay, so let's look at example 2 and 3. So again, in example 2, it is not set up for substitution yet, so we have to find a variable that's all by itself. And I'm also going to show you all how I prefer. This was weird because it had the like the steps on the right, but I like to set it up a little different. So I draw a line. Which variable has a coefficient of positive 1? The y in the first or the second? In the second. This y, if I had to put 1, this would be negative 1, this would be positive 1. So we're going to solve this second equation for y. How do I do that? Minus 2x on both sides. And I get y equals negative 3 minus 2x. So this equation is the one I'm using for substitution, right? So the equation you're using for substitution, you're going to write on the right. This is your sub side, substitution side. Okay? Your other side is the equation that you have not messed with. Which one have I not messed with? The negative x minus y equals 3. This is my one that does not have my substitute. Well, since I know y equals negative 3 minus 2x, I can replace y with negative 3 minus 2x. So when I do that, I get negative x minus, and instead of y, I'm going to write negative 3 minus 2x equals 3. Yes?
It has a does that count as a broken?
Kind of. But we have to distribute it because it's touching my parentheses. So I have this negative x out front. I'm going to keep that because I'm not changing it, but I have to distribute that negative. If you need to, you could put a 1. It's the same thing as distributing just the negative. So negative 1 times negative 3 is what? Positive 3. 2 negatives makes a positive. And negative 1 times negative 2x is positive 2x. Bring down my equals 3. Now at this point, I need to solve. How do I do that? Combine like terms. What are my like terms? What's negative x plus 2x? 1x or just x. Bring down my plus 3 equals 3. Now what? Minus 3 on both sides. And I get x equals 0. Is that okay?
Why isn't it 1?
Because 3 minus 3. Okay, so knowing that, 0 is okay, y'all. Don't freak out if you see a 0. That's allowed. 0 is a number. Yes? So half of my answer is 0. And now, You sure? You good with this? Okay. So now that I know x equals 0, I can replace this x with 0 and solve for y. So I know y equals negative 3 minus 2 times 0. You can type this in your calculator. Negative 3 minus 2 times 0, and it gives me negative 3. Or you can realize negative 2 times 0 is 0, and what do I have left? Y equals negative 3. Can you check your work? Yes. Now when you check your work, don't ever plug it into these. Plug it into the originals that we didn't change. Yes? So if I plug it into this first one, I have negative parentheses x is 0 minus negative 3. And did it equal positive 3? Yes. So then my other one, 2 parentheses 0 plus y is negative 3. Did it equal negative 3? Yes. So we did it correctly. So this is my answer. Any questions with that? Okay, so this next one we like. 2 reasons. First off, it's already set up for substitution, right? Isn't there one that already has a variable all by itself? We like that. Look, this is my substitution equation. Because y is already all alone. So that's my substitute. So that's the equation that's going to go on the right. And I'm going to put the other equation on the left. And because I know that y equals this, I can replace y with this. So I'm going to bring down the 2x because that's not changing, minus 3. And instead of y, I'm going to plug in 2/3 x minus 6 equals negative 15. How do I solve this? Distribute. What am I going to distribute? Negative 3. So I have 2x And now negative 3 times 2/3. If you need to use your calculator, use your calculator. Oop. Gives me negative 2x. And then what's negative 3 times negative 6?
18.
Positive 18 equals negative 15. What happens? The x's cancel out. And do I have any variables left? When your variables are gone, that's what makes it a special case. Because now I have 18 equals negative 15. Is that true or false? False. So what do you think your answer is? No solution. Any questions with that? So here's a question before we flip. What if it was true? For example, like 12 equals 12. It would be infinitely many solutions. So if your variables cancel and it makes a true statement, like 12 equals 12, that means your answer is IMS. So false statements, no solution. True statements, IMS. Now, if you have x equals 0, did your variables cancel? No, I still have x. It just equals 0. That's okay. Okay, x, 0 is a number. Don't freak out about that, okay? These are very different. Okay, when you're done writing that down, I want you to flip to the back. Okay, I know these are everybody's favorite.
Are you being sarcastic?
Yes, super sarcastic. Okay, we have a couple word problems. I know. Y'all are so excited. Okay, so it says City Park Golf Course charges $20 to rent golf clubs plus $55 per hour for golf cart rental. Sea Vista Golf Course charges $35 to rent clubs plus $45 an hour to rent a golf cart. What number of hours is the cost of renting clubs and a cart the same for each course? Well, first off, we have City Park and we have Sea Vista, and we need to come up with two equations. So let's start with the first sentence, City Park. What are they charging? $20. And then it says plus $55 per hour. What does that per tell me? That's where my x goes. And what does x represent? Per what? So I know that x is my hours. Whoop. Which is important to know because we need to know what we're solving for. Is x my solution or is y my solution? We don't know. So we have to figure out what x stands for and what y stands for. And because this is slope-intercept form, it's obviously just going to equal y. What do you think y stands for? Your total. You're exactly right. It's your total cost, your total money. Okay, so now let's look at the next sentence. Sea Vista Golf Course charges $35 for clubs plus $45 per hour for the golf cart. Now, I know that they're both y equals. They both have a variable alone, so we're just going to pick one. I'm going to pick this one. That's my substitute right here. So can I replace this y with the substitute? Well, isn't that really just setting them equal to each other? Yeah, so I have 35 plus 45x equals 20 plus 55x. How do I solve this? I always like to move my smallest variable first. Technically, you can use move anything, but I always like to move my smallest variable so that way I don't have to guess what I need to do. So I have 35 equals 20, and what does that leave me with?
10.
So plus 10x. Now what?
Minus 20.
Minus 20 on both sides. And I have 15 equals 10x. Last step.
Divide by 10.
Divide by 10, and what do I get?
3. No, I'm tripping.
Now we're both tripping.
1.5.
1.5. Okay, now pay attention to what it's asking. Read your question. It says, for what number of hours is the cost the same? I kind of cut out some words, but does it care what the cost is?
No.
Well, what's the only thing it's asking for?
The same.
The what's the same?
The rent.
The hours. So we're looking for hours. Well, what does X represent?
Hours.
So what's my answer? Now remember, word problems get word answers. You have to label your answers. Okay, one more. Okay, it says the math club raised money for a summer trip by washing cars. They charged $3 for a car and $5 for a truck. Suppose the club earned a total of $181 for washing a total of 49 vehicles. Write a system of equations stating these facts. Solve the system. Yada yada. I don't know. What are you gonna say? No. So hold on. So these are going to be written in a different form. The last ones were slope-intercept form. These are going to be standard form. So, because we're given two different totals. And when you're given your total, that means it's standard form because C stands for your total. Okay, so here's my question though. What are my two unknowns? So if you need to read. The number of cars and the number of, no, number of cars and the number of trucks. Okay, so I'm not going to use X and Y because a lot of times when y'all use X and Y on problems like this, y'all lose your X and your Y and you forget what they stand for and you write your answer backwards. So I'm going to use C for cars. So C is my number of cars and T for trucks. T is number of trucks. And now knowing that, I need to write my two standard form equations. So it says $3 for a car, so that'd be 3C, plus $5 for a truck, 5T, equals what? 181 or 49?
181.
181, why?
Because they said the total of 181.
Yeah, because it's money goes with money goes with money. Money, 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 right? $3 is money, $5 is money, 181 is money, okay? So money, money, money goes together. Your next total is 49. And that's your total number of vehicles. Well, what represents your number of cars? C.
T.
Plus what represents your number of trucks?
T.
So C plus T equals 49. And now knowing that it's not set up for substitution yet, but I can make it easily substitution. So which one am I going to change to make it my substitute? The first equation or the second equation? Second. And does it matter which one we solve for? No, because they're both positive, so it doesn't matter which one you get alone. I'll just minus T on both sides. You'll get the same answer no matter which way you do it. So then I get C equals 49 minus T. So remember, that's my substitute. That's why I wrote it on the right. And my equation that I didn't use is 3C plus 5T equals 181. Now I know C equals 49 minus T, so I'm going to replace C with 49 minus T. And that leaves me 3 times 49 minus T plus 5T equals 181. Now what? Distribute. What's 3 times 49? 147. And then 3 times negative T? Negative 3T. Bring down my plus 5T equals 181. Now what? Combine like terms. What's negative 3T plus 5T? Positive or negative?
Positive.
So positive 2T. Huh? Not plus 147, because 147 plus 147 would not be 0. Minus 147.
Wait, why aren't you? Oh, because it has.
Because I'm trying to get t by itself. So I have to move everything else to the other side. And I get 2t equals, I think that gives me 34. Yeah. Last step.
Divide by 2.
And what does t equal?
17.
Now, because I didn't use x or y, I know that's 17 what?
17 t.
Which is t is what?
Trucks.
So I know 17 trucks is part of my answer. Now, because I know that, I know t equals 17, I can replace t with 17. So c equals 49 minus 17. And what does that give me? 32. So 17 trucks and 32 cars. If I washed that many cars and only raised $181, I would cry. It's a lot of work. No? Just me? Okay. Okay. When you're done writing that down, flip. I'm going to talk about the practice really fast. On the front, there's only 6 on the front. Okay? One of them is going to be IMS, and one of them is going to be no solution. If you notice, number 1, number 2, number 4, and number 5 are already set up. You already have a variable all by itself, yes? So there's only 2 of them that you actually have to find, and if you get stuck with that, come talk and we'll work it out, okay? Now flip to the back of your notes. Practice, sorry. You'll see 4 word problems. But what do you notice on the top 2?
Says
Do not solve.
just set them up.
Just set them up. All you're doing is defining your variables if they're not already defined. That's like when we said C equals numbers of cars, T equals number of trucks. And setting up the equations, and that's it. Yes? Now on 9 and 10, you're finding the equations and solving. If you're struggling with finding equations, come get your equations checked before you solve, so that way you're not doing all that work with the wrong equations. Yes? Questions for me? Cool. If you